Coming up on show 897, I'm going to try and explain what Tesla's battery day really means for EVs. Yeah, good luck me. Well, good morning, good afternoon, or good evening, wherever you're listening in the world. Welcome to EV News Daily for Wednesday, 23rd of September. My name is Martyn Lee. I go through every EV story so you don't have to, and I try and save you time. And time really wasn't on my side because I finished at 3 o'clock in the morning this morning watching Tesla's battery day. It was an event that I think everybody, myself included, thought at some point there would be a big ta-da moment. You know, a truck, a Cybertruck appearing, even a Roadster or a Plaid Model S with this new technology already inside and testing on the roads, but there was none of that. This was a very detail-rich roadmap of the next 10 years, and I must admit, when I watched it the first time, I didn't get it. Second and third watches, I understood a little bit more. I spent the last few hours after some sleep fully researching what some of those things meant that I didn't understand, and I've come around to thinking, this is so big, I'm not sure I'll understand it for days, weeks or months yet, but hopefully on the podcast today, we'll get there together. On stage, Elon Musk was joined by Drew Baglino. He's the Senior VP of Powertrain and Engineering at Tesla. We'll talk about 5 big steps they're making over the next, however long they take to get there, 3, 5, 10 years to become a big cell maker. And then they do talk about 2 specific cars at the end, and we'll get to those at the end. So Elon Musk and Drew Baglino took to the stage to take us through the 5 different steps: cell design, how to build cell factories, the changes they're making to the anode, the changes to the cathode, and how they're going to put them in the cars. The first one, the cell design. Well, let's take a listen to this. The first thing they talked about in terms of the cell design was the background to why they needed to make these changes and to make their own batteries. Have a listen to this.
Goal number 1 is a terawatt-hour scale battery production. Tera is the new giga. A terawatt is 1,000 times more than a gigawatt.
And then on the grid side, we have a similar mountain to climb. 1,600 times growth from today's grid batteries to go 100% renewable on the grid and to take all of the existing heating fossil fuel uses in homes and businesses 100% electric.
For Giga Nevada, 150 gigawatt hours per year is like what we probably expect to make out of there. But this is really pretty small in the grand scheme of things. That's only 0.15 terawatt hours.
We would need 135 fully built out Nevada gigafactories to achieve 20 terawatt hours a year. We need a dramatic rethink of the cell manufacturing system to scale as fast as we can and should. One of the things that troubles me the most is that we don't yet have a truly affordable car, and that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down, and we've got to be better at manufacturing, and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough. We've given this a lot of thought over many years to say, okay, how can we radically improve the cost per kilowatt hour curve?
So the essence there is, of all the amazing work they've done with building the Gigafactory in Nevada, they're admitting that, you know what, actually, we'd need 135 of those to hit the targets that we think we need to hit for all of the batteries that we will need. And it's important to say, Elon says it later in the presentation, they're not terminating relationships with existing battery cell suppliers. They're looking to do more. So Panasonic, CATL, LG Chem, maybe more on the horizon as well. Tesla want to supplement that with their own cells. And here is the punchline in this clip to basically the whole of Battery Day. I think the most important thing about Battery Day.
To make the best cars in the world, we design vehicles and factories from the ground up, and now we do this for batteries as well. We have a plan to have the cost per kilowatt hour.
So that for me was the kicker. Now I've read people today saying the most important thing is more range, the most important thing is more power, more energy, supercharging quicker, and all those things. But you know what? I think lower the cost, because then it impacts everything. It impacts the price you pay for the cars, for your home storage, for grid storage, and the most expensive bit of an EV is the battery. Just get that cost halved, and more than halved as well. It's an absolute game changer for everybody. And they revealed that they're making a bigger battery, as in the dimensions. So again, apologies if you know this, I'm not patronizing you, but the original battery cells they used were called 18650s, like big AA batteries. Then they used 2170s, a little bit bigger. And now they are using a new form factor that is, Well, I called it a tin of beans, but it's not. It's smaller. It's more like a jar of olives or the inside of the loo roll when you use the final piece of paper. It's not as big. People have been calling it the biscuit tin online for 2 days. Now, look, if you're having biscuits that small, you got to level up your biscuit game. This is nowhere near a biscuit tin. Not the biscuit tins I have, you know. Maybe I'm thinking biscuit barrel. Anyway, look, here's the clip.
Before we get too far into it, let's talk about what is in a battery cell. We've got the cap and the can, negative and positive terminals of the cell. When you open that cell, you've got a tab connected to those terminals, what we call the jelly roll, which is the wound electrodes on the inside. You can actually see what this looks like as you unwind it. This is over 1 meter long in a typical 2170 cell. So it's quite a long winding process. Anode, cathode, separator, positive and negative terminal. This is the basic of what makes all lithium-ion batteries, no matter what the form factor is. We've moved from the 18650 form factor to the 2170 form factor through great collaboration with our partners. But when we look to the ideal cell design, if we were to do it ourselves, we found a sweet spot somewhere around 46 millimeters. Supercharging and thermals in general become really challenging as you make bigger cells. We came up with this tabless architecture, basically removes the thermal problem from the equation and allows us to go to the absolute lowest cost form factor and the simplest manufacturing process.
The distance that electron has to travel, you know, is just much less. You actually have a shorter path length in a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power-to-weight ratio is actually better. It really took a tremendous amount of effort within Tesla engineering to figure out how do we make a freaking tabless cell. This is like, for people that really know cells, this is a massive breakthrough.
Now, why this is important is because you can use less material in terms of making the battery and the outer shells, because tabless is important. The tab is something that they have to attach to the positive and negative terminals, and when you attach these tabs, you have to slow down the production process. You have to stop it momentarily. Now, of course, that doesn't fit with their idea of the most efficient factories churning these things out 24/7 at a ridiculous rate. So they needed to find a way for the machines to run constantly and quickly and not always stopping to attach these tabs. And so a tabless design achieves that as well. These are the increases they get.
And so when we put it all together, and 4680, we call this new cell design, we get 5 times the energy with 6 times the power and enable 16% range increase, just form factor alone.
So their new bigger cells, which we'll find in all of their cars in the future, their home storage as well, 46 millimeters diameter, 80 meters tall, 5 times the energy, 16% more range, 6 times the power. The one thing they didn't address in this whole presentation was what it means for charge rates. They didn't talk about supercharging, how it will allow faster supercharging, or for that peak rate, which at the minute is 250 kilowatts, to continue a lot further. But all of the research that I've done since hearing this does seem to imply that the gains that they will get from the charge speeds are significant, even though it wasn't addressed in this presentation. And I don't know why they didn't want to address that. Maybe it was a time thing, or maybe they just didn't feel like it was important. But I think it's a huge deal as well, not only for charging quicker, but for having that peak charge rate to hang on for longer, so you can get more electrical energy into that cell and manage the thermal temperatures as well. It's what we all want, right? I don't really want to carry around a massive battery, but I don't mind regular stopping on a road trip if every couple of hours, 2-3 hours, I can stop and charge for 5 minutes or less and top up my battery. I don't mind carrying around 50 kilowatt hours rather than 100 if I know I can charge really quickly. All right, here's the conclusion.
It will take about a year to reach the 10 gigawatt hour capacity. And this is just a pilot plant. The actual production plants will be more on the order of maybe 200 gigawatt hours.
So just the cell form factor change enables a 14% dollar per kilowatt hour reduction, just that cell form factor change.
A standout part of the presentation for me was when Elon said that their pilot plant was on track within a year. And again, I think that's why the share price today was down over 10%, why the markets hated the news. There's no short-term gain for this. This is all real long-term stuff. That, look, I know that you and I get this because it's so exciting. This is their roadmap for the future, but some people didn't get it right. But you listen to that, and now their pilot plant is on track to make 10 gigawatt hours of cells per year. This is their pilot plant. This is their proof of concept. Maybe a bit more than that. But still, like their headline project, which is the Nevada Gigafactory, that makes somewhere around 35 gigawatt hours of cells per year. The exact number not been updated lately. Say between 35 and 40 if we're being generous after recent improvements. That is what they've been working on for years, and they have a pilot project here making just under a third of that in a year's time. And then when they take that from pilot stage to actually building their own cell factory and producing these cells, it's going to be 200 gigawatt hours per year. Truly, truly impressive. So that is covering off, in quite a lot of detail actually, the first of the 5 steps that stacked up to make the benefits they eventually talked about. Step number 1, cell design. Step number 2, and we'll get through numbers 2 to 5 a little bit quicker, is the cell factories. So next we'll talk about dry electrode technology. What on earth is it? Why do I care about it? Well, it turns out that to make a lithium-ion battery cell, you have to make things very wet, and a kind of slurry gets put onto a film or a foil, and then you have to spread it out and bake the thing and dry it, and then you've got to, well, you add some solvent at the beginning, you take solvent off at the end, then you've got to recycle it. They describe it as digging a hole to fill in a hole. And actually, what if you could do all of that without all that wet technology, just with a dry powder coating? And it sounds simple to my tiny brain, and here they are explaining it.
Let's talk a little bit about what's in a cell factory. First, there's an electrode process. The active materials are coated into films onto foils. Then those coated foils are wound in the winding process we just talked about, where if you do have tabs, you have to start and stop a lot. The jelly roll is assembled into the can, sealed, filled with electrolyte, and then sent to formation, where the cell is charged for the first time, and where the sort of the electrochemistry is set and the quality of the cell is verified. Important processes is where it all begins, the wet process of the electrode coating. You've got mixing, where the powders are mixed with either a water or a solvent. That mix then goes into a large coat and dry oven. The slurry is coated onto the foil, huge ovens, tens of meters long, dried, and that solvent then has to be recovered. You can see the solvent recovery system. And then finally, the coated foil is compressed to the final density. Wouldn't it be great if we could skip that solvent step, which is one of those dig a ditch and then fill it kind of things, where you put the solvent in and then take it out and recycle it, and just go straight to dry mix to coat? And that's what the dry process really is about. Literally, powder into film. As simple as that.
It's actually very hard to do what appears to be a simple thing.
And why is this important? Well, it's the biggest chunk of the reduction in cost that we talked about at the beginning of the podcast, of over halving the cost to make those batteries, a 56% reduction. It's actually the largest chunk of that 56%. If you can make the battery cell factories more efficient, smaller, cheaper to build, it has the biggest impact on the whole game. But Elon wasn't very complimentary about the progress they've made. Now, let me explain that more. Lots of people were watching this presentation thinking that any minute they were going to do the big, flashy unveil of a car or a truck or any vehicle, really, and say, and inside it are these new cells, and it's powering it, and it's ready to go tomorrow. And actually, he really kept expectations in check by saying, we haven't really got it right yet.
Even now, at the pilot plant level, it is close to working. Well, it's fair to say it does work, but with not a high yield.
We're still ironing out the kinks, but we've made tens of thousands of cells, thousands of kilometers of electrode. I mean, we are on the 4th generation of the equipment, so we've learned a lot along the way. And
that could be where some of the air was let out of it, where so many people were built up into this sort of frenzy with Battery Day. They didn't expect Elon Musk to come out and say, look, here's a 10-year plan, here's a roadmap, and here's a bunch of stuff that you probably don't even understand. Because, look, hey, I'm not being insulting, I didn't. And so this next clip explains why it's so important to do this. And this clarified it for me. When I heard Drew say this, I was like, oh, right, I get it. Why build 7 lines when you can build 1?
We were able to get to the point where we can implement assembly lines, 1 line, 20 gigawatt hours, 7 times increase in output per line. And when you're thinking about scalability and pure effort, having 1 line be 7x the capability is just effort multiplying.
And then the final piece of the jigsaw was all those companies that I've talked about on the podcast before that they've been acquiring, like Grohmann Automation, or Tesla Grohmann as it's now called, the Canadian company Hybar, that didn't go under the radar, but just no one really talked about. And I was always constantly trying to remind people, look, the Maxwell acquisition with the dry coating, all that kind of stuff, gets all the attention, but these other companies that they've been acquiring, these engineering companies, they are the keys to Tesla becoming their own cell maker, and Drew did reference that.
This is what we're trying to do here is say, okay, how do we, with one factory, achieve what maybe 5 or even 10 factories would normally be required to achieve?
And the vertical integration with the machine design teams at Grohmann and Hybar and others allows us to really accomplish that, because we don't have all these edge conditions between one piece of equipment and another. We can design the entire machine to be one machine and remove all of these unnecessary steps.
16 minutes in, still to talk about anodes, cathodes, structural batteries, and a couple of cars as well, so let's continue. This next story comes to us from the experts at Wired, who frankly are in a far better position to explain anodes technology to you than I am. Researchers at Tesla have been altering the chemistry of their electrodes to boost performance, and also their silicon-rich anodes, which are meant to supplant the more common graphite anodes used in lithium-ion batteries, which, when they're charging, lithium ions flow to the anode, displacing electrons and creating an electric charge. Compared to graphite, silicon can absorb a lot more ions, writes Wired magazine today, or Wired.com. Tesla has been using small amounts of silicon oxide in its anodes for years. The silicon blend effectively comes pre-puffed to reduce damage from swelling, but this means it also enables only modest performance gains. They say that to get a bigger boost typically requires nano-engineering the particles of silicon to retain their benefits as lithium-ion sponges, whilst reducing the risk of destruction. But Drew Baglino and his team opted to take a more simple route. The simpler route is their silicon anodes aren't nano-engineered at all. They're raw silicon stabilized with some elastic ions. According to Drew Baglino, this can increase the range on its own of a Tesla by 20%. And from that story in Wired to The Verge today, and let's talk about cathode technology. Tesla plans to build a new cathode plant in North America to reduce supply chain costs and simplify things as well. The current process is not efficient, and it's making improvements to the process that'll make cathodes themselves 76% cheaper and produce zero wastewater. The new process will eliminate many of the intermediate steps involved in cathode production, and it plans to diversify the cathodes it uses using there's a low nickel supply, so they will be using alternatives, they said, and that story coming to us from TheVerge.com. So Tesla getting into some serious factory building. And what about the final piece of the jigsaw? Well, that was the fifth step, which is to make Tesla's battery packs integral to the car to the point at which they are part of the structure, not just made into modules made into a battery pack and bolted up underneath the car, which is, frankly, how everyone is making EVs, well, dedicated EVs. Some are stuffing batteries under seats and places if they're trying to convert an ICE platform, but if they're making their own skateboard platform, everyone's making cells into modules, modules into packs, and then just bolting it up underneath the car. What Tesla said that they are going to do, they've been doing this for however many 10 years now, and they say, you know what, in the next couple of years, they're going to completely change the way they think about how the battery pack works inside the car. They're going to make it structural. So they're going to get rid of those modules, so they're not going to be making those lots of smaller bits to make a bigger bit, so the cells will go directly into the car. But what they will do is they will use a compound between those battery cells that are cell-to-pack technology that is both a flame retardant and an adhesive and part of the strength of the car, so that a single molded piece, so these massive casting machines they're putting into all their factories, gigafactories around the world, that will make the single rear end of the Model Y, and the front, by the way, the single front, those single cast pieces will simply bolt onto, that's the front and the back of the car, they'll come together, the middle bit of the car will start at the bottom with the battery pack, but it will be part of the structure. And Elon's saying, even if you make a convertible this way, or a soft-top car, it would still be a lot stronger than a hardtop car that you would think would be stronger because it had a full frame, but it adds that much strength to their cars. And I thought this was an open goal that he would have said, oh, and by the way, this is how we'll be making the Tesla Roadster. But no mention of that. So clearly the focus was not on talking about things like roadsters at this particular event. So that was the fifth and final part. Now, all those things do stack up. We spent longer on the first two parts, admittedly, but all those things do stack up together. So the cell design, the cell factory, the anode, the cathode, and the cell vehicle integration to make 54% increase in range, 56% reduction, so over half, like I've been talking about, dollars per kilowatt hour, and a 69%, nice choice of stat there, investment that they have to make for every gigawatt hour of cells. It reduces by over 2/3 the investment they would have had to put in to get those gigawatt hours of energy or stored energy produced, which is just utterly, incredible. The more I digest it, the more I realize how huge this news is, and none of it will make a single bit of difference tomorrow or next week or next month or even in 2021. But when it comes, it's just going to be an absolute night and day change for automotive and their energy business. And that's where, when you start to take a step back and think about the bigger picture and think, I know that Tesla said today that they were going to be making 20 million cars a year by the end of the decade, and that's doable, right? That's about 2 Volkswagens. It's such a massive target, but that's okay. But actually, I think that'll be dwarfed if they really can get this battery technology and the manufacturing technology as well to where they talked about today. They genuinely will have been a company that changed the world. They won't just be a company that destroyed the combustion engine, which would be a nice legacy to have. They genuinely will have been a company that played their part, and a really big part, in the storage of renewable energy, which of course is the world's biggest problem. We've got enough sun and enough wind and enough other renewables. So what do we do with them? How do we store that energy? And Tesla today, the cars are all well and good. And you may tune into this podcast for car chat, car stuff. But actually, the bigger picture is how we store energy, how we go about our lives when you and I are all 20 years older, touch wood. Hopefully plenty of us are still around then. And it just made me hopeful today. It made me hopeful for a future when there's so many negative headlines around about climate change and what the hell we're going to leave behind on the planet for the next generation and the generations after that. And the more I think about it and sit with a cup of tea and ponder what we heard, it's actually that attention to storing energy I think could be the biggest thing today. But now I'd love to know what you think about what they said about cars. So there were a couple of cars mentioned. Holy moly. It wasn't particularly sexy, but it was a couple of big things, a couple of big pieces of news. Firstly, it was the news about a $25,000 car. When do we get it? Not yet. It won't be coming anytime soon. But Elon once again reiterated that a $25,000 Tesla is on the roadmap, and all of this that we heard about today will be a way that we access that. And then Tesla Model S Plaid Edition. Yes, that is coming. It's a tri-motor. It's going to be 0 to 60 in less than 2 seconds. It'll do the quarter mile in less than 9 seconds. And it's over a year away. And again, it could be a reason why today people were a little bit deflated, because that was meant to be now. Like the Plaid Model S was meant to be now. We heard a year ago-ish. So, or at least by the end of the year. And Elon's saying, and all of this advances that we make, we're going to roll all this into a Tesla, a 3-motor Tesla Model S Plaid Edition, and that'll be on the market by the end of 2021. So over a year away. Again, that could have been a reason why I think a few people were like, oh, we thought there was going to be more car stuff. It was definitely an event that took a little bit more understanding than I was prepared for, but I'm glad I put the hours in to understand it. I feel good about doing that. I hope I've done that a good enough job for you on the podcast today, but now I'd like to know what you think as well, please. Was that okay? And it's a long one as well, it's 25 minutes, but did that help in some way? I hope so. Let me know your thoughts. What do you think about the things we've talked about today and the things that that you heard on Battery Day? You can email me, hello@evnewsdaily.com, and you can leave a comment on the YouTube show. Well, I really couldn't put this show together without the support, the very kind support of the patrons of this podcast. Patreon, patreon.com/evnewsdaily. If you want to have a look, see what it's all about. It's the thing that allows me to spend more time on this than otherwise I would, paying the bills and paying the mortgage and keeping the lights on and things like that. So thank you so much for all of your support and my premium partners I mention every day. Thank you very much to you, Phil Roberts from Electric Future. Such a good name for a company, isn't it? Brad Crosby, AVID Technology, Porsche of the Village in Cincinnati, Audi of Cincinnati East, Volvo Cars of Cincinnati East, NationalCarCharging.com and AlohaCharge.com, and Derek Riley from the EV Review Ireland YouTube channel. Have a wonderful day. I will catch you tomorrow. And remember, there's no such thing as a self-charging hybrid.